Welcome back, grade 12s, to grade 11, right? Okay, so we're doing our trig revision, and as we're doing it, hopefully bells are ringing and we're remembering things and getting all excited again, right? So, we're asked to prove an identity. We're asked to show that this left-hand side is equal to this right-hand side. And just a quick thing on proving identities. This isn't an equation that we're trying to solve. So we're not going to go, oh, well, let's find an LCD for the whole equation, or let's multiply both sides by 3 or something like that. You're going to pick the left-hand side, work with it, or you're going to pick the right-hand side and work with it, or you're going to pick the left-hand side and work with it and pick with the right-hand side, but they're never going to interact with each other. Okay, and hopefully the one turns into the other. Okay, let's do it to remind ourselves what all of that hassle meant there. So I'm going to pick the left-hand side. The reason for picking the left-hand side is it looks A, more complicated, and B, it's got tan in it. Now, if we have tan, we know that tan theta is sine theta over cos theta. Useful little one that is going to be, well, useful, right? So, therefore, tan squared theta is sine squared theta over cos squared theta. If we had looked at the right-hand side, we might have gone, hey, there's a cos squared theta, and we also know that sine squared theta plus cos squared theta equals 1, our squares identity. And based on that, we also know that cos squared theta, well, if we subtract sine squared from both sides of the equation, we'll get another variation. And if we take the original and we subtract cos squared from both sides, then we've got 1 minus cos squared theta. Okay, so we got those just at the ready. So let's take the left-hand side and tell our reader which side we picked, so it's clear what we're doing. Okay, so the numerator, I'm just going to draw my fraction line here nice and big. That's that fraction line over there. And say, well, we've got 1 minus sine squared theta over cos squared theta. And that we're going to divide by 1 plus tan squared theta. Well, we've got some double-decker fractions going on here, which we're going to sort out in a step or two, because there's so much going on, you see I had to get the really thick Cokie out. So let's stick with it for now and go, well, here we go. Zoop, there's our fraction line. In the numerator, I'm going to take this oh, that's a little larger than life. We're going to take just look at the numerator here and write that as one fraction. So I'm going to pick an LCD, and my LCD for the numerator is cos squared theta. Okay, well, this was 1 over 1, so it still needs to be multiplied by cos squared theta. What you do to the bottom, you do to the top, so that's cos squared theta for the first term, and there's nothing to do for the second term. Okay, let's do something similar on the denominator. Our LCD over there is also cos squared theta. And similarly, this is 1 over 1, so we need to multiply it by cos squared theta, and the second term stays the same. Okay, quite a bit going on there, especially with the scary double-decker fraction. Now, we're dividing here. Some of you may see this already, that you can cancel those there. But it's not that evident. So if you can't see it, that's okay. And we're going to do it in the longer version. But if you can see it, use that. It's really handy to see it as well. So we're dividing by this over here. So we're taking the numerator. So we're taking the numerator and we're dividing by the denominator, which was, blah-de-blah over cos squared theta. But instead of dividing, why don't we do a tip and time? So I'm going to change the divide to a times, and therefore I'm going to tip this, what we're dividing by. And I do want to do this in one step, because it's going to take too many steps to split this up. So I'm just going to write it down and see if we can see it once it's written down. Okay, so instead of dividing by that bottom fraction, we're going to times by the reciprocal, tip and times. Okay, but the numerator stays as is, the thing that we dividing first here. Okay, so sine squared, cos squared. Okay, so that was a whole lot of extra work, ostensibly so that we could see this cancelling that I wanted to do in the previous step. Because we're left with cos squared theta minus sine squared theta over cos squared theta plus sine squared theta, which if we had cancelled here, we would also just have seen. Okay, and I'm saying that quite forcefully because it's just, it's useful if we could have skipped that step there. Okay, so we've got cos squared theta minus sine squared theta over, wait a second, what's cos squared theta plus sine squared theta? Well, I wrote that up here. Here it is. That's just the number 1. So, over 1. Well, therefore, I don't have to write divide by 1. It's already there. So, that's fine. Equals 1. So far what we've got, writing sort of an extra step here, is cos squared theta minus sine squared theta. Now, sometimes in these, I find we need to just rewind and go, wait, where are we getting to? We're trying to get to 2 cos squared theta minus 1. So we're trying to turn that into 2 cos squared theta minus 1. Feels like we almost there. Now where we're trying to get to has only got cos squared thetas. It doesn't have sine squared thetas. So let's keep our cos squared theta and change our sine squared theta into cos squared thetas. Well, we've got a way of doing that up here. And that is sine squared theta is 1 minus cos squared theta. 1 minus cos squared theta. But I'm trying to look at the reasons why we're choosing to do various things. And my reasoning here is where we're trying to get to only has cos squared thetas, no sine squared thetas. So therefore, let's change that. Well, cos squared theta minus 1 minus cos squared theta is just cos squared theta minus 1 plus cos squared theta, which is 2 cos squared theta minus 1. Now, one last thing. I've said a lot of things about these identities. Be careful of the steps you show, and more importantly, the steps you don't show. I didn't show multiplying this negative in and going, oh, well, that's the same as minus 1 plus cos squared theta. Feels safe. We could go from there to there. Of course, we know what our answer is. But it would have felt very unsafe to say, oh, well, I know that that must just turn into what it's meant to turn into. The reasoning wouldn't be clear enough. So be careful of which steps you show, and more importantly, which you don't. Okay, well, that was quite a lot of thinking about the identities, but it's also because we're only practicing one. So onwards, upwards, see you in the next one.